We have spent almost all of our time with the normal distribution and its cousin, the student's t. Now it is time to branch out a bit and meet the chi-square distribution. The chi-squared probability density function is what you get if you sum up k-independent standard normal distributions squared. The formula would be written: chi-squared is equal to z1 squared plus z2 squared, etc., to zk squared. This doesn't really tell us much, but I felt I needed to tell you where this thing came from. As it turns out, the distribution has a number of very interesting uses. Classic examples are: n wine judges rate k different wines. Are any wines ranked consistently higher or lower than the others? Or how's this? N wines are each rated by k different judges. Are the judges' ratings consistent with each other? This particular question is solved by a statistical test, which is a variant of the chi-squared distribution invented by Milton Friedman, a Nobel laureate in economics, and famous for his work criticizing the Federal Reserve Board actions during the Great Depression of the 1930s, and perhaps most well known as one of the founders of the so-called Chicago School of Economics. The fundamental chi-squared distribution was first described by the German statistician Friedrich Helmholtz in the late 1800s, and was then rediscovered by Karl Pearson in 1900. The chi-squared is useful in a number of ways, but we are interested in only one: testing hypotheses about a variance. Thus far, our interest in inferential statistics has been exclusively focused on the population parameter mu, or its counterpart in the binomial p. There are other cases, however, where we are interested in the variability of the outcomes of some distribution. In almost all production processes, quality is measured not only by how closely the machine matches the target, but also the variability of the process. In short, statistical tests concerning the variance of a distribution have great value and many applications. In this unit, you will learn how to calculate the degrees of freedom for a particular problem you are trying to solve, as well as how to form the null and alternative hypothesis for tests of a population variance against a particular value. You will also learn how to read the chi-squared probability density function table and conduct and interpret chi-squared single variance hypothesis tests.